Hello my friend, I hope you're doing well. My name is Sarang Borude and I love building beautiful spatial computing apps. In today's video, we are going to make this magical hidden box in your table that you can hide virtual objects into. This effect is really cool because it overlays AR content on physical real-world objects such as a table and creates a feeling that it's a part of this world. To add to the realism of this, I'm going to give the objects some physics capabilities such that they can interact with the surfaces of real-world objects. To make this box, we'll have to touch a lot of concepts in visionOS app development. We'll look into how to use an occlusion material to hide virtual objects. We are also going to look into how we can use anchor entities to attach objects to real-world surfaces. Then we are going to look into how to move entities using simple animations. And then we are also going to implement some gestures and apply these gestures to specific entities. And finally, we'll dive a little deeper into ARKit to use plane detection so we can do physics collision between our virtual objects and real-world surfaces. The GitHub repo for this project is down in the description, so don't forget to check it out. 2 weeks back, when I started working on this video, my grandma passed away, so I want to dedicate this video to her. We were very close and I miss her a lot, and I hope she's in a better place right now. Now let us jump into making this box, shall we? We will start by creating a new visionOS project called Hidden Box Tutorial with a window and an immersive space. When our app loads, we have the content view that has a button to show the immersive space. Then we also have some files like the app model file and the Hidden Box Tutorial app file, and we have our immersive view right here. For this project, we'll be doing most of our work in the immersive view. Our immersive view has a body that has a reality view, and the reality view loads the immersive content entity from our RealityKit content bundle. Let's open our Reality Composer Pro project by going into Packages, RealityKit Content, and the package right here. Our immersive scene by default has 2 spheres and a grid material, and we are going to delete them first to start from a completely empty scene. I'll start by pressing the plus button in the bottom left corner, selecting Transform to create an empty transform and rename it as Box. And I want to add a cube to the scene, so I'll click the plus button in the top right corner and add a cube from it, and I'll make this cube a child of our box transform. Let's also change the size of this cube to 100 centimeters or 1 meter, as it will make it easy to later position and scale the cube. Now I'll open the content library one more time and add a material for the cube. This time I'm going to go into the wood section and pick the maple plywood material. I'm going to delete the default material that's on the cube and replace the material on the cube in the material bindings to the maple wood material. I also don't like the color of this material, so I'm going to change it a little bit, make it more warmer. Now I want to scale and duplicate this cube multiple times to create the bottom and the side faces of this box. Let us start by selecting the cube first and then renaming it as base. Now I'm going to change its scale to 0.5 in the x-axis. I'll make it 0.25 in the z-axis, and I'll make it 0.005 to make it super thin in the y-axis. This is what one face of our box looks like after the scaling. I will also double check to ensure that our box transform is at 000, and same with the base, it needs to be at 000 as well. Now before duplicating and making other faces of the box, I'll add a collision component to this entity, and I'll also add a physics body component to this entity. I am setting the mode to static, and I am disabling is affected by gravity, so when the scene loads, the cube just doesn't fall by gravity. Now I will make other faces of the box by duplicating the base, setting its position, and also scaling them appropriately. Our box is now ready, and all the faces of our box have the collision and the physics body component. Now let's go see how our box looks on device, but before we do that, we'll have to go into Xcode and position it a little bit so it appears in front of us. I have set it to be 0.7 meters above the ground and 0.7 meters in front of us. Let's see how this looks on device. So when we run the app and press show immersive space, our box just loads and floats midair. Now what I want to do is make sure that our box is anchored to the table right here. So let's do that. First, I'll remove the lines that add and position our Reality Composer Pro scene into the Reality View's content. To anchor our scene to the table, RealityKit provides us something called anchor entity. In an anchor entity, we can specify that we need a plane, and we can also specify what kind of plane we need, like do we want it to be horizontal, we want it with the classification of a table, and we can also define minimum bounds of this detected plane. And then we'll add this detected anchor to the content of our Reality View. Now what we'll do is, once our Reality Composer Pro scene loads, we'll make it a child of this detected anchor. So what Reality View does, it will attach our loaded scene to this detected anchor, and it will be visible after the anchor is detected. Let us see this on device. So now when we open our immersive scene, what RealityKit does, it starts looking for any anchor entity that fits our defined specifications. So a plane, that is a table, and once it loads, it will load our Reality Composer Pro scene on it. So you can see the box sitting on the table. Our box is now sitting on top of the table, so I want to push it down a little bit so it appears that it's inside the table. I can do this by subtracting the height of the box from the position of our immersive content entity, which is going to be 0.25 meters. You can now see that our box sits under the surface of the table, but there is a problem that we can see the side faces of our box. So we need to do something so that the side faces and the front face of the box are now occluded. To create this effect, we first need to duplicate all the faces of the box, set an occlusion material on it, and offset it to the outside. I will start by duplicating the base entity, and I'm going to rename it as base occlusion. Now let's create the occlusion material. I'll hit the plus button in the bottom left corner, create a shader graph. I'm now going to delete the preview surface node that's in the shader graph and add a occlusion surface node here and attach it to custom surface. And that's our shader. I'm going to rename it to Occlusion Material. I will now apply this occlusion material to our base occlusion entity that we have. So I'll replace its material. And now I'm simply going to offset this base occlusion entity a little bit to the outside of the base, and you can see that it already hides our base. Now I'll repeat this step for all the other faces of the box. After doing that, you'll notice that we are running into this problem of our edges of the box are now still visible. So to mitigate that, what we are going to do is we are going to increase the scale of each occlusion face a little bit so that it hides the edges. You can see after doing that, our box is fully invisible from the outside. Let's quickly try and run it on the device. So you can see now that our box is appearing to be a hole on the table, and when you look it from below, you can see that you don't see the front or the side faces of the box anymore. Now we can work on creating this effect of opening the box. We can do this by creating two cubes with occlusion material near the top of the box and sliding them sideways. I'll start by duplicating the left side of the box. I will rename it as top left underscore occlusion, and then I'm going to rotate and position it. I'll duplicate this one more time to create the top right side of the box. I will now update the materials on these two objects to the occlusion material that we created. You can see that because of setting the occlusion material on these two objects, it completely hides our box. Now to animate the opening of the box, we'll slide the top left occlusion object to the left and the top right occlusion object to the right, and that will create the animation of opening the box. We will do this by setting up a spatial tap gesture that will allow us to trigger the animation. I'll close the top of the box one more time, and now what I'll do is I'll duplicate the base to create a surface for detecting the spatial tap gesture. So I'll rename it to be top collision. I'm going to set its position a little bit above the box. Maybe at 27 centimeters. Now I'll create a new material for this top collision object. I'm going to start with a shader graph, and I want to create like a transparent material, so I'll start with the unlit surface node. I'm just going to connect its output to the custom surface, and that's our material. Let's rename it as transparent material. I'm going to change the color of this material to be green, and then I'm also going to change its opacity to something super low like 0.1. I'll now apply this material to our top collision entity. So this entity is going to be invisible, but we set this material to it so because when we are developing the app, we can change its opacity to debug things. On the top collision entity, we don't really want any physics collisions to be happening, so we are going to remove the physics body component from it. And because we want to use it for our spatial tap gesture, we are going to keep the collision component and simply add a input target component to it. So now that we have set the components up, what we are going to do is we are going to detect the spatial tap gesture on our top collision object, and after detecting that, we are going to trigger the animation to open the box. We are now back in Xcode. We'll start by creating three state variables to store our three entities for the box top left and right and our top collision that we just created. We'll also add a boolean here to check if our box is open or not. So now we need to find these three entities in our Reality Composer Pro scene. And we can do that by calling find entity function on our immersive content entity, which is basically an entity that loads our Reality Composer Pro scene. So we can provide the find entity function a name, and here we are going to double check the names of our three objects. So you can see here the object is top left underscore occlusion, and I'm going to make sure I'm going to type the name without any errors. I'll also do the same for the top right occlusion entity and also the top collision entity. And if we find them, we'll save them into our state variables that we created above. Now we'll add the code for our spatial tap gesture. So our spatial tap gesture will be targeted to our box top collision entity that we created. We can specify that with the targeted to entity modifier by specifying the box top collision. And now we are going to basically play the box open animation, and we haven't really implemented this yet, but let's just do that. The play open box animation function is very simple. It simply checks if the box is open or not, and if the box is open, what it's going to do is basically going to create copies of the transforms of the box top left and the box top right entities. Then what we are going to do is we simply add offsets to the left transform and right transform to where they are supposed to be moved. And then we use the RealityKit entities move function to this target transform, and we move our box top left and box top right entities to the left and right transforms. We can also specify a particular duration and a timing function here to smooth out the animation. After the animation playback is complete, what I want to do is I want to remove the entities that we have found so that the animation will not be repeated again. So what I'm going to do is I'm going to use combine, and I'm going to create a cancelable state variable, and I'm going to subscribe to the completion event of this animation. So we can do this subscription on any one of our moving entities, which is the box top left or box top right. What we are going to do is we are simply going to go into the box top left entity, into its scene, and we are going to create a publisher, and we are going to specify that this publisher is going to be for the animation events payback completed event on our box top left entity. And when this animation completion event gets fired, we are simply going to remove our entities from there. Let us run this and see what it does. So you can see here our top collision entity is visible here. And as soon as we do a spatial tap gesture on it, it opens the box. And as soon as the animation is complete, our top collision object gets removed. I also want to show you that because we have a spatial tap gesture set up, we can simply poke the top of the box and it opens as well. Now I want to hide the top collision object, and I'll do so by changing the opacity of the transparent material by setting it to 0. You can see now our object is completely invisible. And this causes a problem that when the object appears in front of the user won't be able to see it. So we need to create some kind of affordance that will let the user know that they can interact with this object. We can do this by creating a particle system. I will create a particle system by clicking the plus button on the bottom here and select particle emitter. The particle system component in RealityKit provides you with some presets. So I'm going to start with the magic preset here. Now I'll make the particle emitter a child of the top collision object. I'll rename it to some suitable name. Let's call it invite particle emitter. Our particle emitter is not visible yet. You can see that her transform is set to like world, but you can click on the 3 dots on the transform component and simply remove the overrides, and it will reset the position of the particle emitter. And you can see that when you hit play, you can now see our particle system here. Now this particle system does look good as is, but I want to make sure that it is kind of spread out so that it takes up the whole area of the top collision object. So let me make some changes to it. I'll start by changing some emitter settings. So I'll change the idle duration to 5 here because I want the emitter to fire every 5 seconds. Now I want to update the emitter shape size, so I'll go to the emitter shape size, change its X coordinate to 0.6 maybe. I'll keep the Y as is and 0.5 on the Z axis. Now you can see that it spreads out our particle emitter effect on the top of the box. While we are at it, I also want to create another particle system that gets fired when our box is now open, just inviting interaction to the objects inside the box. I'll create another particle system by selecting the particle emitter here. And for this one, I want to start with the snow preset. I'll make this particle emitter a child of our base entity and then rename it as open particle emitter. So this particle system will play after our box is open. To visualize the edits we are making to this particle emitter, I'm going to move our top left and top right occlusion entities to the side. Let's see how this animation looks. We can do that by selecting the emitter and hitting the play button. So you can see that it's falling downwards. So there's a bunch of settings we need to change here. I'll position it towards like 10 centimeters relative to the base. So it's a little bit higher than the base. And then in the emitter settings here, change the speed of it. So I want to make it a little bit slow. So I'll reduce the speed and the variation by 50%. So 0.04 and 0.02. I want to now reverse the direction of the emitter, so I can do so by changing the emit directions Y component to 1. And then I'll play around with the emitter shape size so that it kind of fills up the whole box. Now let's change some particle settings in the particle emitter. First, I think that there are just too many particles here, so I would want to change that. Now I'll change the birth rate first to, let's say, 25, and then burst count to 5. I'll also increase the lifespan of the particles to 10 so they live a little bit longer. Now I want to change the color of the particles, so I'll just change the end color, maybe make it from the range of like orange to yellow. Now I'll change the blend mode of the particle textures to be additive. I feel that they are scattering too much, so now I'm changing the noise strength to be 0.01, so they are just like coming out and going straight up above with a little bit of noise. And that's how it looks. I will now close the box back up by changing the positions of top left and top right occlusion entities. You can see one problem here, that our particles are coming outside the box even if the box is closed. We can fix this by disabling the isEmitting property on the particle emitter component. We will enable this flag when our box opening animation is done playing. So let's go back into Xcode and figure out how to do this. We'll start by creating one state variable to store the particle system that is supposed to play after opening the box. Now we can use the findEntity function to find this particle system in our Reality Composer scene. So we'll jump back into Reality Composer Pro, just make sure that the name is right. So it's called Open Particle Emitter. And here we can make sure we are specifying the name without any typos. And we'll save the reference in our state variable. Now, in the block where our animation completion for the box opening gets fired, we'll simply find the particle emitter component of our particle emitter, and we'll set its isEmitting flag to true. And then we'll set back the particle emitter component back to the open particle entity. So why did we get the reference to only one particle system? The answer is over here. So what happens is, when this animation is completed, we are removing the box top collision object from our scene. And as our initial particle system is a child of the box top collision object, it gets removed as well. So we don't have to do anything else to stop it. Now let's try running this. So you can see, as soon as RealityKit finds our anchor entity, our Reality Composer Pro scene is loaded. You can see that the animation is happening on the table for the initial particle system, and the user can go and interact with it. Now, after the box is completely open, the first particle system gets destroyed, and you can see that the second particle system is enabled. Now let's make this more interactive by adding some more objects into our Reality Composer Pro scene. So I'm just going to pick some objects from the toys section in the Reality Composer Pro library, and I'm going to add all of these objects and position them towards the base of the box. So we added all the toys we needed. We also positioned them and scaled them appropriately at the base of the box. We just have to make sure that none of the toys are sticking out of the box from any sides, as it will break our illusion. Now we want to interact with these objects, so I'm just going to select all of these objects first, and then what I'm going to do is add some components. I'll start by adding a collision component on all of these objects. Then I'll add input target component so we can manipulate them with gestures, and those are all the components we need right now. Let's make sure to close the box again. Now we are going to implement a drag gesture on all our toys, but to do that I just want to make sure that when we do the drag gesture it only applies to anything that's a toy. So I'm going to create a new component and I'm going to call it toy component. So what this toy component does, it simply is an identifier that anything that's a toy. And we are going to filter our gesture only to the objects that have toy component on them. We are back in Xcode and here we are going to set up our drag gesture on a reality view. Here I want the drag gesture to only affect our toy objects. So I can do that with the targeted to entity modifier. The targeted to entity modifier takes a query predicate, and in that we can specify that only affect the entities that has a specific component, so in this case the toy component. Our gesture has an onChange closure in which we can get access to our entity to which we are performing the manipulations to. So here we are simply manipulating the entity's position. The value variable in the onChange gesture also provides us a 3D location of the gesture. We cannot really directly use this location 3D as we have to convert it before we apply it to our entity. So we can do this with RealityKit's convert function that will convert the location 3D object from local space to the entity's parent space. Now if you run this code, you'll notice that your manipulations are simply not working. This is happening because we have not registered our component. So we'll simply go and register our component in the init function of our Immersive View, and our manipulations should now work. So now when you open the box, you can see toys inside the box. And you can simply pick the objects from the box and you can place them wherever you want. So we can manipulate our objects and that's very cool, but wouldn't it be very interesting if our objects had some physics and interacted with like real world surfaces? Like, wouldn't it be cool if we can place these objects on the piano behind or on the table or even on the floor? So let's look at how we can do this. To add physics to our toy entity, we'll need to add a physics body component to it. But I also want to create this effect that when it's being manipulated, the physics on it is turned off so it doesn't collide with anything else or the detected planes. And when I release it, it gets the physics components and then reacts to the physics forces. So in the onChange closure, I'm going to set the physics body component on the entity to none. And now the drag gesture also provides us with an onEnded closure, and in that onEnded closure what I'm going to do is I'm going to generate a physics body component. I'm going to give it a specific physics material and then I'm going to set it on the entity. So now you can see that our entities have physics on them and they can fall due to gravity. But let us see what will happen if I release them outside the box. So here I release them and they'll just go and fall into the abyss and not land on the table or the floor. So to fix this, we'll have to do some plane detection on real world surfaces using ARKit. I'll start by creating a new Swift file. I'll call it Plane Tracking Manager. And I'll add some headers that we're going to need. Now I'll add the observable property wrapper and I'm going to create a Plane Tracking Manager class. We'll start by adding some properties to our class. So first here we create an ARKit session, and then we are going to create a plane detection provider because we are doing plane tracking. We have this content entity, which is the root entity that will store all our detected plane entities. Here we also have a plane entities dictionary that will store the anchor UUID that gets detected and the corresponding plane entity that we create. Then we have some boilerplate code that helps us check if the plane detection provider is supported on our device, and also if our plane detection provider is initialized. Then we have this function called setup content entity, and we'll call this function from our Immersive View right over here that returns us the root entity, which we then add to our reality views content. We will add some more boilerplate code to set up ARKit. So here we are creating this function called monitor session events, and all this function is doing is basically watching our ARKit sessions events, so we can check if our user has provided the authorization to run ARKit plane tracking, if the user has denied it, and we can also check when our data provider, which is our plane tracking provider, has changed any states. We'll create another helper function called run ARKit session that we can call from our Immersive View to start running the ARKit session with the given tracking provider. So the plane detection provider in this case. Next, we will be adding the process plane detection updates function, and this is going to be the most important function here. We'll get rid of the warnings and errors in a bit, but just so you understand that this is the main function that handles any sort of anchor updates we receive from our plane detection provider. Let us first start by getting rid of these warnings and errors. I'm going to add some extensions to geometry source, geometry element, and mesh resource at the very bottom of this file that I found from Apple's sample code. We'll look into this in a bit. We can also see a bunch of these warnings that say that this expression is async but not marked with an await. To get rid of all these, we can add the main actor property wrapper to our plane tracking manager class. That should get rid of all the warnings. Now let's try and understand what the process plane detection updates function is doing. This function is simply awaiting any anchor updates from our plane detection provider. There are usually three types of anchor updates that we can get from the event property of the anchor update. These events are for plane anchors getting added, updated, or removed. When a plane anchor is removed, we know exactly which plane anchor was removed from its ID. When this anchor update is for removal of a plane anchor, what we can do is we can simply use the removed plane's anchor ID to detect which specific plane was removed, and then from our plane entities dictionary, we can get the entity for our removed plane anchor, and then we can simply remove this plane entity from its parent that causes its removal from the scene. Now let's see what we need to do when plane anchors get added or updated. We will start by creating an empty entity, and then we'll give the entity a name. We can use the anchor ID for the name of the entity. Now we need to set the position and rotation for this entity. So we get the transform for the detected plane anchor from the origin from anchor transform property on the anchor. So this transform has the information of the position and orientation of the plane anchor, and we are going to use the entity set transform matrix function to setting the position and orientation of this newly created entity to match with the detected anchor. So our entity right now is just an empty transform. So we need to add model component and collision component to it for our collisions to work. So let's take a look at that. So let's first look at how we can add a model component with a mesh to our entity so we can visualize the detected plane. I would like to make a note that the model component is not really necessary for doing the collisions, but it's helpful for visualizing our detected planes. So to create our model component, we need a mesh resource and a material. Here I'm creating the material for the mesh. So I'm creating an unlit material with the red color. And I also want to control the transparency of this material. So I'm going to set its blending to transparent, and I'm giving it an opacity. Currently it's 0, but let's say for debugging purposes to visualize our mesh, let me increase its opacity so we can see it. So let's make it 0.3. Now we are going to create our mesh resource. To create our mesh resource, we are going to use our anchor's geometry. So to create the mesh resource, our mesh resource content struct does not really have an initializer that takes in anchor's geometry. This is where we'll be using the extensions that Apple's sample code has provided below. Our anchor geometry has mesh vertex and mesh face data. And what this extension is doing is simply converting the mesh vertex and mesh face data into specific arrays that can be used by the mesh resource content struct initializer. So here you can see that we are converting the mesh vertex data as SIMD3 float arrays and the mesh faces as uint32 arrays. So now once we have created our mesh resource content struct object from our plain anchor geometry, we can simply use the mesh resource generate function to generate the mesh resource. And then we can use it to create our model component. Now let's take a look into creating our collision component. Now this is going to be very similar to what we have done earlier. It's just that instead of creating a mesh resource, the collision component requires a shape resource. So let's see how we can create this shape resource. We can create the shape resource using the generate static mesh function that takes a vertex buffer and the face index buffer, both of which we can get from the anchor's geometry. So here you can see that the geometry has the mesh vertices, and from that property we can simply convert it using the asSIMD3 helper function. Let's take a look at this function now. So you can see here it's simply taking the vertex data and simply converting it into a SIMD3 float array. The generate static mesh function also needs the face indices to be into a uint16 array, so we'll use this as uint16 array helper function from Apple sample code. So let's take a look at this. Here you can see in the geometry element extension that we are simply taking the geometry element data and converting it as a uint16 array and returning it. If this is getting too complicated, just try and understand that we are simply converting our geometry data into a format that our shape resource and mesh resource initializers would like. So now we pass this generated shape resource into the shapes array of our collision component initializer, and then we simply add a physics body component with its mode set to static, as our physical world planes will not be moving. And then finally we set this fixed body component to our entity, which allows our plane entities to collide with our toys. So now our entity is ready, and now we want to see how we'll handle them differently when the event is either addition of a new anchor or updating the new anchor. So if this anchor is getting updated, what we'll do is we'll take out the old entity from the plane entities dictionary using the anchor's ID, and then we'll replace this entity with the new entity that we just created. We'll also add the newly created entity as a child to our root content entity that holds all the planes. And then we'll remove our old entity from its parent, that will remove it from the scene. So for addition of a new plane anchor, simply adds the entity to our plane entities dictionary, but nothing gets removed as nothing already exists in our plane entities dictionary. Now we can go into our immersive view and see how we can call these functions. But before that, for our ARKit code to work, we need to make some changes to the info plist file. So let's do that. So we'll click on the hidden box tutorial, which is our project in the top left. And then we'll go into the info tab, which is where the info plist is. And we'll create a new key here. And we are going to add the NS world sensing usage description key over here. And here we can give the user some description as to why our app is going to need ARKit for tracking. Now we'll jump into Immersive View and add the functionality to do plane tracking using ARKit. So first, I'll start by creating a state variable that initializes the plane tracking manager. And now in our Reality View's make closure, we simply need to add our root entity from our plane tracking as a child of the content of the Reality View. So we can do this by calling the setup content entity function in our plane tracking manager, which returns our root entity, the content entity that has all the planes added to it. This line of code is very important, as because of this, our detected planes get added to our Reality View's content and they can interact with our other toys. On our Reality View now, we are going to set up 3 task view modifiers. In the first one, we call the monitor session events function, where we await any events that are getting fired from the ARKit session. The second one calls the run ARKit session function, and that essentially starts our ARKit session and starts detecting the planes. And the final one here will allow to execute our main function to create our entities for the detected planes by calling the process plane detection updates. Now let us try and run it. So now when we run the app and when we hit the show immersive space button, we get a permissions prompt that asks us our permission that this app would like access to your surroundings. When the user hits allow, the plane tracking immediately begins, and you can see our detected planes are now appearing in red everywhere. As soon as RealityKit detects our anchor entity of the type table, it will load our Reality Composer Pro scene there, and we can interact, and it opens the box. And let's try picking up an object, and I'm really hoping that when I release this rocket right here, it should stay on the table. And it doesn't. So let's try to figure out why it's not working. So our physics collisions are not working because RealityKit does this optimization where it only allows collisions between entities that are under the same entity hierarchy. So we need to put our toys in the same hierarchy as our detected plane entities. So what we'll do is we'll simply add this one line of code here where our gesture ends. We are simply going to change the parent of our toy entity. We are going to change its parent to our content entity in our plane tracking manager, which basically is the parent for all our detected plane entities, so the collisions will work. I have also set the preserving world transform true so that when the parent changes, our entities retain the same world space position. Let's now go back to our plane tracking manager where we are setting the material for our detected planes, and we can change its opacity back to 0 so we don't see them. Now let's try running our app. Okay. So now as our table gets detected, we can interact with it. Now the box opens, and now I can simply drag and move the entities and place them on the table. And they are not falling down. I can also set them directly on the floor or the piano, and they'll stay on the surface. There is one problem we can notice here, that our toys are visible from over the table. And you can solve this problem by applying an occlusion material on the detected planes. The only problem that will cause is that it will also hide our box inside the table. So we cannot really use it here. So we can do something clever like it doesn't create an occlusion material over the top of the surface of the box, and that is something you can figure out. You made it to the end of this video, and I hope you liked it. If you did, please don't forget to like and subscribe to the channel. I really want to thank you for your time you spend watching my videos, and I will greatly appreciate if you can share my videos and my channel with other VisionOS developers. If you want me to cover specific topics, please leave a comment below and I can cover that in a future tutorial. That's it for this one. I'll catch you in the next one.